And welcome back to Review Unit 12 Circles. We just finished number 6 and number 7, and now we're off to number 8. Number 8 says, a candy machine creates a small chocolate wafers in the shape of circular discs. Circles, okay. The diameter, which is the distance from one side through the center to the other side of the wafer, is 16 millimeters. That's the diameter. Well, whenever they ask me for the diameter, they typically ask for the radius. So right away, I know the radius is half of the diameter, so 16 divided by 2, or 8 millimeters. So now they're asking me, what is the total area of this circular disc of 5 candies to the nearest square millimeter? So I have to find the area of one of these. Well, the area of a circle, if you look on your reference sheet, is pi times the radius squared. So the area of one circle is pi times the radius, which we found to be 8 squared. So the area of one wafer is going to be, let's put this in here, 8 squared times pi is 201.0619298, but they want 5 candies. So we're going to take the area of one of them and we're going to multiply that by 5. So the area of 5 circular candies is equal to 1005.3. And they want me to round to the nearest square millimeter, which means to the nearest whole number. So I'm rounding to this 5. So my final answer is 1005 millimeters squared. Easy as pie. And now we are on to the last page. Number 9 is a multiple choice question. It says in the diagram of circle A, so remember A is going to be our center. Below, we have a chord CD, which is just a segment that touches a circle in 2 places, and chord segment EF, that's here. They intersect at G. Fantastic. And chords CE and FD are drawn. Which statement is not always true? Well, let's take a look here. I'm actually going to kind of skip around. And I'm going to start with choice, because CG, I'm not really sure about this. CG and FG, is that not always true? I'm not really sure. So let's go to choice 2. Angle CEG, where is that? Angle CEG is actually this angle here, which intercepts arc CF. So that's an inscribed angle. That angle is half the arc. And is that congruent to angle FDG, which would be this angle here, which, oh, look at that, it intercepts the same arc, which means these angles will both be half of that arc. So these 2 angles will always be true. These are inscribed angles who intercept the same arc will always be congruent. Okay, so we're looking for not always true. Okay, let's look at choice 3. Angle CGE, that's this angle here. So we know that this angle and this angle are congruent. Okay. So 2 arcs around this angle. And angle FGD. Oh, those are vertical angles. Vertical angles are always congruent. So this will always be true. So let's look at choice 4. It says triangle CEG, so it's this triangle here, is similar, this means similar to triangle FDG. That's this triangle here. Well, look what we just found from choices 2 and 3. We have these 2 angles will always be congruent. These 2 angles will always be congruent, which means a third angle will always be congruent. So this is true, because if you have 2 angles congruent to 2 angles, then the triangles will be similar. Which leaves us with choice 1. I wasn't sure. This is not always true. It could be true, but it's not always true. Number 10. It says in the figure below, segment AB is a diameter. Okay, well, diameter forms 2 semicircles, 180 degrees each, of a circle with a radius of 34 miles. Well, if the radius is 34, one radius is 34, then another radius is 34, which means the diameter is 34 plus 34, and this is miles, which is going to be 64 miles. Okay, if AC is 32 miles, determine the length of CB. Okay, so we'll call that X. What do I have here? I have a triangle, and I have two sides of a triangle, and I'm looking for the third. If this was a right triangle, I could use the Pythagorean theorem. So let me see. Let's go back to this diameter. If AB is a diameter, then doesn't that mean that this semicircle, this arc AB, is 180 degrees? And if we lead that back to angle C, isn't this angle an inscribed angle? So angle C is half of 180, which is 90 degrees? Oh, wow. Okay, so angle ACB is an inscribed angle, which is half of arc AB. So that's where we're getting this from. So it's going to be half of 180, which is 90 degrees, making this a right triangle, which means the two legs are A and B, and the side across from the right angle is always our C term. So now we're simply going to use the Pythagorean theorem. So A squared plus 32 squared equals 64 squared, right? The length of AB. So the two radii added together give us the diameter, which also gives us the hypotenuse of this triangle. Fantastic. Okay, so we have 32 squared, and that gives us 1,024, and 64 squared is 4,096. So when we take 4,096 and we subtract 1,024, we end up with 3,072. So A squared is equal to 3,072. Hold on. Back up one step. I made a mistake back here, didn't I? 34 plus 34 is not 64. 33 plus 3 is 6. 4 plus 4, this is 8. I apologize over here. Let's go back to our Pythagorean theorem. I was all excited because this is just like a little puzzle piece, and I find it very exciting. All right, so let's go back. 68 squared is, how about 4,624? 4,624. Sorry about this. And now, when we take 4,624 and we subtract 1,024, we end up with 3,600. That sounds much better. Okay. So the opposite of squaring is square rooting. So therefore, A, which I said is CB, the square root of 3,600 is 60. So CB is 60. So let's just go back and review that real fast. They gave us that AB is a diameter. The radius, so half the diameter, is 34, which means both radii of the same circle are going to be congruent, which means the entire diameter is going to be 68, not 64. And AC was 32. Determine the length of CB. So we found out that angle C was an inscribed angle, which means it's going to be half of its intercepted arc, which is a semicircle, so half of 180, forming our right triangle. So we did A squared plus 32 squared plus 68 squared. The side across from the right angle is always our C term, which is always the hypotenuse. So 68 squared. So that's where we got the A squared plus 1,024 equals 4,624. I apologize for that mistake. And when you subtract, you get 3,600. And when you do the square root, you end up with 60. Okay, one last question and you are done with Unit 12. In the diagram below of circle O, so by now you should know O is the center, diameter BC, and radius OA. So let's talk about this for a minute. All radii of the same circle are congruent, okay? So that means all radii of the same circle are congruent. So OB is congruent to OA, is congruent to OC, okay? All radii run from the center to any point on the circle. So these three radii are all congruent. It says chord DC is parallel to chord BA. Okay, so these two segments are parallel. And we talked about this in a previous problem. We end up with alternate interior angles, congruent alternate interior angles. All right, so it says if the measure of angle BCD is 30 degrees, Determine the following. Well, what did we just say? We said that angle BCD, oh, that's not the angle, is the letter Z is here. So then this angle is also 30 degrees. So if angle BCD is 30 degrees, that's an inscribed angle. It's going to be half of this intercepted arc, which means arc DB will be 30 times 2, which is 60. All right. Then look what we have here, this pink triangle. If I highlight this, actually, let's highlight this in blue. This is a radius. This is a radius. This is two congruent sides of this triangle. Look at this. We have an isosceles triangle, which means angle B is going to be congruent to angle A. So these two are going to be congruent because angles opposite, congruent sides are congruent. So let's see what else we can do. It says find the measure of angle AOB. AOB. Well, okay, we have a lot of information here. That's part of it. There are a couple of different ways to do this, but one of them is that this angle is part of the triangle. So we know that the triangle sum of all the interior angles is 180. So if we take 30 plus angle AOB, that's going to be equal to 180. So 30 plus 30 is 60. Plus angle AOB is 180, subtract 60, angle AOB is going to be 120 degrees. So I'll put that in there. That's 120. Now they want us to find the measure of angle ABC. ABC. Well, we found that out already. That's 30 degrees because of the congruent, alternate, interior angles formed by those parallel lines. And then it says the measure of angle OAB. Well, we found that out already. We said that was 30 degrees because angles opposite, congruent sides are congruent, or you could have said base angles of an isosceles triangle are congruent. So a couple of different ways you could do that one. And the measure of angle AOB, which is the same as part A, it's still 120 degrees. So you guys are doing a fantastic job. I just want to show you, some of you I know went ahead and you did things a little bit different. You could have also found out some of these angles. You could have found out the rest of this arc over here by doing 180 minus 160, 180 minus 60. That would have given you 120. Okay. Let's see. A lot of different ways that you guys can do this stuff. So I'm going to leave you with that and not give you any more information because I'm getting a little excited about all this information. I like circles. They're like a big little puzzle piece to me. So you guys have done a great job. This is Unit 12. I hope that you are reaching out to your teacher if you have any questions, concerns, or problems. Have a wonderful day.